All right, so we switch the x and y. We're going to solve. You've got x minus 1 equals 2y cubed. Divide by 2, you get y cubed equals x minus 1 over 2. And then we cube root. You do not need a plus minus for any of the odd roots. Okay, when you learned about radicals and roots last year, you should have learned that if we are dividing under a root, that is the same thing as taking a cube root of x minus 1 and dividing by a cube root of 2. And am I allowed to leave a radical in the denominator? Not if I'm simplifying, which, I mean, the rules really aren't simplified, but we are simplifying. So where you guys were not going far enough is you're leaving that 2 in the denominator. So we need to rationalize it. So we're going to multiply. It has to be a cube root so that I can multiply underneath the other cube root. It has to be a cube root that I'm multiplying by. And when I'm done multiplying, I need the root to disappear. In order to make the root disappear, I have to have something cubed. Something to the third power and a cube root undo each other. So Abby, do you know what you did wrong yet or not yet? Maybe. Okay, so if I have 2 to the first, I'm going to multiply by something. What to the third do you think I need when I'm done? Okay, guess. I want 2 to the third when I'm done. Okay, I right now have 2 to the first. I want 2 to the third so I can cube root it. What do I need to multiply by? Gracie.
4.
The number 4, which is 2 to the second, right? Which is the number 4. I'm just going to write 2 to the second because I'm thinking about exponents. If I've got 1, 2, and I multiply by 2 times 2, I've now got 2 to the third, which is the number 4. Those are the same thing. When I do that, I will get the cube root. Nope, I won't get the cube root, sorry. When I do that, on the bottom, I will get just 2. On top, I will have the cube root, and then I just distributed. There's no reason to distribute or not to distribute. Nothing makes one better than the other. So that is my final. Now, I did not tell you how to figure out if it was a function or not. So I'll go off to the side and talk about that. I told you it was, but I didn't tell you how to figure it out. So, obviously you could graph 2x cubed plus 1, but let's say this is on a non-calculator part. 2x cubed plus 1. So I know that an x cubed looks like this and is a function. What does the 2 do to it? Vertical stretch. So right now, if I just take this and I stretch it by the 2 arrows and I pull on those ends, it's just going to make it less curvy. And then translate up 1. So I'm just going to translate that up 1 with less curves. So does the horizontal line test work? Yes, so the vertical line test would work. But if my original cube looked like this, then it wouldn't work. So it is important that you know what the original looks like, but I'm not going to, if it's a non-calculator part, it's going to be stuff you know how to graph without the calculator. Okay. Finding the inverse of a radical function. Let's go ahead and I'm going to have you try it first on your own. Find the inverse of example 5. If you're done and waiting to go on for that one, you can try number 6 also. I'm going to pause the video. Okay, so you guys, you had no problems finding the inverse. A few of you just did different orders on when you squared it. I would actually divide by 2 next. There isn't necessarily a wrong way unless you make some mathematical errors. So I get x over 2 equals square root y minus 3. Then I squared it. So I got x squared over 4 equals y minus 3, and then I solved for y. X squared over 4 plus 3. Okay, but then I'm going to look at my original, and my original is, it's a square root. It's a little bit taller than normal. It's stretched vertically, and it's also moved 3 to the right. So I'm just sketching this like rough draft here. So I know it looks like that. And then I look at my new function, which is a parabola that is wider than normal, and it's up 3. So what does that tell me about these two reflections? Something's not right. Can I have one being a parabola and one being just half of the square root type thing? No. Like, they both need to look the same. The blue one was given to me, so I need to make the pink one look like the blue one. So I need to tell my equation that you can't use this part. So we're going to tell that equation that we can't use that part. Christopher, did you figure it out? I apologize. The maths are very hard. I could hear part of what you said. Could you just repeat it for me? Yeah. Okay, you said it right. Greater than or equal to 0. So we're just saying use the stuff on the right side of the graph. Now, I did not say use greater than or equal to 3. A y is greater than or equal to 3. Some people had that written down because you were definitely thinking, oops, some of you had this written down, you were definitely thinking that you needed a restriction, but if I say y is greater than or equal to 3, well, that's both halves. The only way I can get the right half is using an x restriction. Okay? All right, the next one. This is the reason why we had to go over that other example at the very beginning. We've got a rational function. Let's find the inverse first. Then we'll go graph everything. Sound good? Let's find the inverse first. Can you guys find the inverse first? Find the inverse first? Okay, I switched x and y. What did I do after I switched x and y to get that third step written there? Who did that? What did I do? Somebody's talking, but I don't know who it is. Barry, did you know what I did? Right. I just cross-multiplied. Another way that you might have seen this and thought the same thing would be, well, I need to multiply both sides by y minus 2 so that I don't have fractions anymore. So I just cross-multiplied. Okay, now what I'm doing is I'm solving for y, which means all of the y's need to be on the same side of the equation, which they are not right now. So I'm going to move the y by subtracting it. So I'm going to have xy minus y. At the same time, I'm going to add the 2x to the other side. Just do it in one step. And now I've got xy minus y. Okay. Xy minus y equals 2x plus 1. All right, I have to get y by itself, which means y cannot be in both of those terms. Do we know how to get y by itself? Who was that? Lainey, good job. Yeah, you're going to factor, you're going to GCF, factor that y out. And I'm going to have x minus 1 And I have y by itself, so I'm going to divide both sides by x minus 1. And I need to know if the function is, if the inverse is a function. Now, I haven't graphed the original one yet, but going back to my notes that we did earlier in class, it's going to be this kind of shape. Does a horizontal line test work? Does a vertical line test work when you inverse it? Imagine if I took this and I, where is it at? And I drew a line right down the y equals x and we reflected it. It's almost going to look exactly the same. It's not going to change which quadrants of those asymptotes it's in. So it should be a function. These should all be functions. You won't have to use the horizontal line test for all of them, because some of them you can just look at and be like, those are always functions, like lines. Always functions. Sorry, it's mine. Okay, now let's talk about graphing it. Here's the tough part. It's not that tough, but here's the tough part is x plus 1 over x minus 2 is not in the form of 1 over x. So that's not a transformation form. But I can show you how to put it in a transformation form so you can make a transformation table. Because currently it's not. Okay? And you learned it last year. What does this line mean? What's that line mean? What's that over mean? X plus 1 over x minus 2? It means divide. So guess what I'm going to do? I'm going to divide. Remember long division? Memories! No. This one's really easy, though. Let's long divide this. X goes into x how many times? Once. Okay? Now I'm going to distribute that 1 to the x. I'm going to distribute the 1 to the minus 2. And then we have to subtract, which I don't like to subtract. I like to add opposite. So I'm going to change it to subtraction, and then I'm going to add it instead. I'm going to change the signs and add it. The x's cancel out, and I get 3. Now we were going to rewrite that exact same thing. F of x equals, I meant to write it in blue. F of x equals 1 plus the remainder over the divisor. Done. It is now in transformation form. I'm just going to rearrange it so it looks more like the transformations we've been doing. But it is now in transformation form. What does the 3 tell me? I'll just make a table while you guys are thinking about that answer. What does the 3 do to the original function? Jacob? It is a vertical stretch, so I will take my verticals and multiply by 3. What happens if I take y equals 0 and I multiply it by 3? What if I take a horizontal line and I stretch it vertically? Can I take something horizontal and stretch it vertically? Do lines have thickness? They only have length. They don't have width also, so you can't multiply 0. I mean, you can multiply 0 times 3, but it's still 0. So this doesn't go anywhere. It's still at 0. All right, finishing it up. 3/2. Okay, good. Took care of the 3. What does the minus 2, the x minus 2, what does that minus 2 do? can tell me. -2. Transformations. It's going to be on our test coming up. Makes it go right. How much? 2 to the right? Okay, so on my x side, I will add 2. Can I add 2 to x equals 0? Can I make x equals 0 go to the right 2? It's a vertical line. Can it go to the right? Yeah. Translations will move it. Stretching's not going to move the asymptote. So it'll be x equals 2. And then we have that +1 on the outside. A +1 on the outside. Vivian, what's the +1 do? Okay, we're going to translate up 1. So that goes on my y values. So does that take a horizontal line? And if we go up 1, does that move the line up 1? So y equals 1. Okay, so I'm going to graph asymptotes at, and like all the asymptotes, they stay in line with each other. We just don't need the stuff in the middle anymore. X equals 2 and y equals 1. So I've got my asymptotes, and then I've got some points to plot. And then we just know that these graphs should get closer and closer to the asymptotes. They look like these little branches, kind of like almost web-like. Oh, I missed it. So once you have some points, it should be pretty easy to just estimate the rest. Not looking for perfection on these. We're just looking for some points that are correct. So how do we graph the inverse? That's the function. We haven't even graphed the inverse yet. How do we graph the inverse? Sam, how do we graph the inverse? Okay. So how can I do that accurately? Ryan, can you help him out? Because this doesn't, like the asymptotes themselves don't hit on that y equals x line, so this is not completely centered. Can you help him, Ryan? Or? Yeah, see that big table I made? I didn't do that for no reason, right? I get all of my inverse points out of that table as well. We just switch the x's and y's. I'll do it in a different, I'm doing it in a different color already. I don't know what color. Pink, I guess. It's kind of close to the red, but. So what do I do for asymptotes? Is that part of the x and the y's? Yeah. So I'm going to switch the x and the y's. I'm going to switch the asymptotes too. I'm going to have y equals 2, and I'm going to have x equals 1. Those are going to switch. So at x equals 1 and y equals 2, and I'm just going to switch all the ordered pairs. So I'll have -1/2, 0. -2, 1. It gets confusing because I made my my two asymptotes too close together in color. Yikes. We should have made my second asymptote green or something. Here, I'll highlight it in a different color. That will help me. This is my second asymptote. Sorry, I'm like struggling trying to not look at everything. -5, 1.5. So make sure you stay close to the actual asymptotes. This one's pretty hard because they're so close together. The ones in the assignment aren't as close together. Then I've got 7, 2.5, 4, 3, and then 2.5, 4. So I hear people wanting to ask me questions.
Yeah, well, this just looks like that. It's very confusing.
Yeah, I know. Let's see if I can. Okay, question. Could you tell transformations on this? Could you tell a difference on this one? The ones on the assignment won't be as close together as this, but literally all I'm doing is switching the x's and the y's, and I'm sorry that this one's really close together. You're right, it is hard to see. Okay, but you just need to be able to switch the x and the y's. If you want to do like your original in black and then your new one in a color so it pops out more, maybe that would be a good idea. Just know that it is a little hard to see. We're almost done. This last example does not take very long, especially if you don't make any silly like arithmetic mistakes. So there's one last section that says to verify algebraically that these two given functions are inverses. What I mean is I do not want you to take f of x and just solve it to find the inverse and make sure it matches. That's not what we're doing. We're doing something that's closer to a proof, where you're literally going to do f of g of x, you're going to put them inside each other and show that they will undo each other and give you that y equals x line. So that's what you're going to do. You have two steps. You have to show that f of g of x equals x, so we need to show that they undo each other and give us x. You also need to show that g of f of x also equals x. So we learned how to do f of g of x and g of f of x in section 1.7. So we're just going to repeat that process. But you got to show steps like a proof. So we're not going to combine steps. We're going to show everything as a separate step. So f of g of x, I start with f, and then I put g inside. I replace the x with g. And then I'm going to simplify. So if I have x plus 1 divided by 3, and then immediately multiplied by 3. What happens if I have x plus 1 divided by 3 multiplied by 3? I just get x plus 1. The 3's will cancel out. Okay? Then I've got x plus 1 minus 1. X plus 1 minus 1, that's 0, so I just get x. It worked. Check mark. Second one. We have to show g of f of x is also equal to x. So I'm going to start with my g, x plus 1 over 3, and I'm going to put in my f equation, 3x minus 1. I'm going to do my order of operations. 3x minus 1 plus 1 goes first, so that's 3x over 3, and 3x over 3 is x. So I have verified that these are inverses by this method. If you don't use this method, you will get 0 credit. Okay? So on the assignment, on the test, you will be asked to verify. So there's two more of the exact same thing. I want you guys to work ahead, see if you can do these. Yeah, take a moment, see if you can do these. I'm going to silently write work up here so it takes less time, but I want you to see if you can do them. So I went for went through the work for question B, and when I did f of g of x, I got 16x. When I did g of f of x, I got 2x cubed root x. If you did not get those answers, you need to look at your work. Now, you will either get both check marks or both not working. There is not a possibility where one would work and the other one would not. So if you were to get one that did work and the other one didn't work, that should tell you you're doing something math wrong. Arithmetic wrong. What, Christopher? Nope. You're going to verify it. You're going to go all the way to simplified to show me that they're not. And I'm glad you can see that ahead of time. Remember when you did proofs and you hated them because you're like, I can just tell. Why do I need to write down every step? Remember that? Yeah. It's the same thing, and we don't do a lot of proofs, but you're just going to write down every step. Sorry. Lane, you got a question?
Did you forget a 2 in the numerical?
Yes. That should be a 2, not an X.
Okay.
I didn't forget a 2, I just wrote the wrong thing.
Okay.
Thank you. Sorry. That's a 2. Yesterday when I was working on an answer key, I wrote 92 down, and then I looked at my hand, and I had just written 29. I knew what I was writing. I was like writing 92 and looking at something else, and I looked down, my hand wrote 29. Explain that one to me. Does not listen to this. It's got its own mind. Okay, the last one, did you work ahead, or are you still on that one? Okay, so I'm going to do it. Okay, so when I distribute here, I get positive x minus 4, then add 4. So this does equal x. That means the other one has to equal x, or I'm doing something wrong on one of them. So I'm going to double check. Works. So I know the bell for athletes are going to ring in just a moment. Just want to remind you about your assignments. If you're not looking ahead, this book page 106, there's like 5 problem-solving questions that were on there last week that said it will be due on Thursday, and now we're adding on this 1-8 worksheet plus some questions in the book. This worksheet that I've made you will have extra space for you to do the book work and extra graphs for you to do the book work on it. If you're not using your own paper. Yes.
So is problem solving due next Thursday? Or
No, this Thursday. It was on last week, so that's probably why the word says next, because I just copy and pasted it. Yeah. Is that your same question? Yeah. So it's due next class. So really we only have one section, but then there's 5 problem solving questions. If you're looking ahead, you will notice that we do have a test coming up. If you're looking ahead, you can see what the review looks like for the test.